Hey guys, welcome back. Today's topic is about the number systems. So, number system is nothing but a writing system which is used to express our numbers. So, in day-to-day life, we use number systems called as decimals. So, we use decimal numbers. For example, if you say 20 kgs, 30 kgs, 40 kgs, all this kind of numbers, 29, 39, these numbers are decimal numbers. So, it's been used by us and it is for our convenient. So, in this, as you can see, we have 10 numbers in this 0 to 9. So in decimal number we have 0 to 9. Using this 10 numbers we can go up to infinite. Okay, so adding one just left side to the previous one, we can increase the value. As you can see, this 30, how can be it represented? Since it's an units digit, it will be represented in normal. It's in 10, it can be represented as 3 into 10 plus 0. Okay, can I represent a decimal number in this? Yep, you can. So let us consider a number x. So x and y. So this number can be represented as such: x and x plus y into the base of the number. What is mean by base? Base is the number of distinct digits in a number system. So let us consider our number system is decimal for now. So and then the base will be 10. Why the base will be 10? Because we have 10 numbers, 10 distinct numbers, 0 to 9. So our number will be 10x plus y. So this is the basic of the decimal number. So we have different types of number systems. As you can see over here, we have different types of number systems: binary, octal, decimal, hexadecimal, and base n. This is a customizable. Whatever you can write, that's base n. For example, if you want 5, then it's base 5. So what's a base or a radix? So base or a radix is that number of distinct digits in that number system is base or radix. So binary means that we have two distinct digits, 0 and 1. So binary, where we use binary? Computer systems uses the binary thing. So this binary is used by computers and some logic design systems. And computers also use octal number systems. So what's mean by octal? Octal means it's base 8. That means we have number of distinct digits is 0 to 7, 8 digits. So base is 8. As we know, decimal number systems we use normally in our day-to-day life. So we have number of distinct digits is 0 to 9. That means 10 as the base. Hexadecimal, we have 16 as base because we have 16 distinct digits. 0 to 9 it's common, but after 9 we have a different naming. 0 to 9 it's common. So after 9 it is 10. So 10 is represented as A. 11 is represented as B. 12 is represented as C. 13 is represented as D. 14 is represented as E. And F is represented for 15. I will give you a small question right now. Why did we use A, B, C, D, E, F instead of 1, 0, 1, 2, 1, 3, 1, 4 and 1, 5? So why didn't we use this one? Why did we went for this one? I want you to answer in the comments below. If you know that answer, please comment down below. If you want the answer, comment down below. Okay, so this is how hexadecimal. So for base n, we will use 0 to n minus 1. For example, if we have base 3, if it's base 3, then number of distinct digits are 0, 1 and 2. Okay, 0, 1 and 2. So I have a small question for you. Can you tell me what's the 8th number in the base 3? 8th number in base 3. But there are only 3 values. How can you say 8th number? Okay, that's your doubt. So let's find out what's the 8th number. As you can see, the first number is 0, second number is 1, third number is 2. So as you go for in decimal, after 9, what you do is you go for 10. How did 10 came? First number and 0 again. Similarly over here, use 1 and 0. It's 1, 0. Next, 1, 2. Next, go for, sorry, it's 1, 1. Next, it's 1, 2. So 3 numbers finished. So after 1, 0, you'll go till 19. Then after you go for 2. Similarly, go for here. Go here with 2, 0, 2, 1 and 2, 2. So now what happened? All our 3 digits has been finished. So 2, 2 has been completed. So after 2, 2, what will go? Go back for 1 and extend for 3 bits. So as you can see, this is how you write in a base 3 or a base n. So it's, what's the 8th number? It's 1, 2, 3, 4, 5, 6, 7, 8. So 8th number is 2, 1. So this is how we need to do if anyone asks base n and what's the number. Okay, so I'm now gonna give some examples how are we gonna write base in a decimal number. So if it is, let us say a number 67, so how it is recognized as a decimal or a binary or octal? It's not binary because binary doesn't have 6 and 7. How can be it recognized whether it's octal or hexadecimal? So to distinguish it, we have to write like this, braces and 10. So this indicates the base is 10. Okay, so in binary it's 0, 1 and 0. So there is no other number than 0 and 1. So no problem, it looks like binary, but it can be decimal or octal or hexadecimal. So to distinguish it, we need to write base as. Base is must in number system. Don't forget to write base. That will lead you a huge mistake because you don't know which number systems are doing. Okay, and in octal, let us consider this number. This number can be decimal or hexadecimal. So if you write base 8, we represent it as octal. And now go for hexadecimal. Let's write FF. So FF is not found in others, but it's better to write the base 16. Okay, you can also have like this 1, 3, 5. So to distinguish these two, we need to write base 16. So okay, these are how we represent it in the bases. Now let's go for some examples. So how do we calculate in binary or hexadecimal how a number system represents? So this is our number is representation of a number. So whatever is on the left hand side, it is the MSB. Whatever which is on the left hand side, it is LSB. So what is meant by MSB? Most significant bit, and LSB least significant bit. So it has the highest weight. Highest weight means highest value. It has the least weight means least value. That's what I say. So for example, in decimal, let's take 67. So 67 base 10. So you know that its unit and it's tens place. So how can we represent it? 6 into 10 plus 7. Okay, so it's 67. So it has the highest weight 10, it has the least weight, it's 1. Okay, this is LSB and this is MSB. So this is how our number is represented. So let us take some examples and solve in other decimals, other number systems like hexadecimal and octal. So what's the value of this? It's 1AF. So how can you do this? So it's so simple. So F into 16 power what? Least value, it's 0, plus A into 16 power 1 plus 1 into 16 square. So what's the value? 16 square. Just give the answer. 256 plus A. What is the value of A? It's 10. 16 into 10, 160 plus F. F, what's the value of F? 15. So combine this. 256 plus 160 plus it's 431. So 431 in what? In decimal. Okay, in decimal, and this value is in hexadecimal. So this is how you get a value from hexadecimal to decimal. But don't worry, I'm going to take about the conversions in detail in other video. So this is how you need to calculate. So I'm going to give you one more example before completing this video. Hey, this is a tricky question. So if you answer this, you got the number system. If you answer this, you got the number system. So answer this in the comment whether it's correct or not. If you want the answer, please continue watching. If you want to think your brain, then stop watching here and okay, let's go. So what's wrong in this? What's wrong in this? As you know that it's a tricky question. It's base 5. Understand, this is a base 5, and what we represented it is 5. Base 5 doesn't have 5. You know, base 5 can have only 4 distinct digits. 1, 2, 3 and 4. 5 cannot be represented as 5. 5 need to be represented as like this in base 5. So what? This is totally a wrong one. So we cannot represent 5 in base 5. Okay, don't trick by this small technique. This is what most people use. Okay, don't listen. Number systems, 5 means 4 distinct digits. You cannot represent 5. Okay, if you have any doubts on number systems, what have a thought, please comment down below. That would help me a lot to make videos better for you. And if you like this video, please do like, share and subscribe. I'm not forcing you, just asking or begging. Okay, whatever you can think. Thanks for watching. Hope you like this video. See you in the next video.